Okay, welcome to a review of Code Interpreter, the plugin that is currently in alpha at the time of this recording. But guess what? There will be no code whatsoever. So I want to focus on logic. And the reason I want to focus on logic is because I think the discussion on the value of language models has moved so far in the direction of how it can generate copy or generate text based on its understanding of language that we've even created a moniker called generative AI. I know it's well accepted. I personally don't accept it only because that's not where I think the real value is. It also brings the case that there's a lot of focus on the lack of truth in the copy that's generated or the answers it's providing. To me, none of that really matters because the real true value of these language models, especially moving forward, is going to be their ability to reason, looking at them as a reasoning engine. So let's dig into that a little bit and talk a little bit about why Code Interpreter is a good environment for this experiment. So first of all, the kind of thing that I think GPT in general is showing us is that there's an additional kind of regularity to language which has to do with the meaning of language, beyond just this pure part of speech combination thing that everybody's really focused on. So I think the best example of that is what we've had in the past with logic. So Aristotle uncovered logic by realizing that there's a structure to sentences. Specifically, this concept is called syllogism, where he, as a human, just observed other humans talking, and over all these different observations, he detected that there are patterns. That's this form of reasoning where a conclusion is drawn from two different or assumed propositions. He was able to make that discovery by observing humans with very small data sets, for that matter, while they're actually talking. And he realized that there's a structure to the rhetoric that doesn't matter what the content is. It's just P's and Q's. You can abstract the details of these particular sentences. You can actually lift out this formal structure, which became logic. So ChatGPT, the assumption is that it's operating at Aristotle's logic level. It's essentially dealing with templates of sentences. I want to challenge that by using Code Interpreter today to do some Boolean logic tests. So what's the difference? Well, Boolean came much later than Aristotle, and Boolean logic is really based on some challenges to Aristotle's logic, but it really builds upon it. So what I want to focus on today, we're going to do this experiment called truth tables. In our 10 tests today, I'm going to do 10 truth tables, one of the most common ways to test comprehension of Boolean logic. So we're going to see if there is a next level logic or if it's just pattern recognition that's more of an Aristotle type of logic, or is this a Boolean logic? And the reason that I think this is really interesting to do within the context of Code Interpreter is because Code Interpreter is not just an input and output to the GPT-4 model. Wait a minute, did I say GPT-4? Not entirely sure what model. I assumed it was GPT-4. I've been working with this for a couple months now, and the one thing I do notice is that it's very slow compared to GPT 3.5. I can say actually I've lost connection to the model interpreter and it just kind of defaults over to another model. Very strange behavior. Again, haven't seen that in a while, but it gets a lot faster when that happens. I'm under the impression, and I have been in extensive testing, I probably have 100 or so conversations with Code Interpreter so far. I very much so, based on the output I'm getting and the speed at which I'm getting the output, I think that GPT-4 is behind this. However, if you ask Code Interpreter itself, it tells you that default response based on its cutoff, it is based on the GPT-3 model, which at the very least, it's going to be the 3.5 model. So I'm not sure how much we pay attention to that. I actually did web browsing, which really I just saved myself from Googling. And it came up in a couple of different cases as saying that it's a GPT-4, but it's also citing a Reddit thread. And it does cite also the release notes from ChatGPT, but I have dug through those significantly. And believe it or not, there is not specific access to which model this is in the documentation. So let's move on to 10 tests. So what we've done here, I've actually pulled a escalating level of complexity example truth tables to test against the model. And in the interest of time, because like I said before, I was getting some pretty significant wait times on drawing these, I have already loaded this into Code Interpreter, the alpha plugin, which again, I speculate is using GPT-4. The important thing though, is that it has access to a Python execution environment. Adding code to GPT has a powerful side effect, like programming languages like Python demand logical structure, clear commands, and specific syntax. So when you combine code and the logic that there is in code to GPT, whether it's 3, 3.5, or 4, you can potentially improve the model's ability to reason and generate text in a more logically structured and coherent manner. And that's the the hypothesis of which I'm operating under here. So 2 hypotheses. Adding code to your language model gives it a whole nother level of logic and therefore reasoning, which can be very useful in other non-generative applications. And number 2 is that it's not just Aristotle level logic in GPT, and of course we're just focusing on GPT here, but potentially Boolean level logic. So let's go with the 10 test truth table test. Thanks for hanging in there up until this part. So let's jump right into the first one. So the very first truth table, the question, so to speak, is not P or Q. And you see the tables over here. These are the correct answers on the left-hand side. Let's see how the code interpreter works. So first of all, it's giving an explanation of its work. P and Q are propositional variables that can either be true or false. And we're going to use P and Q as we move forward with all the rest of these tests. And so the truth table lists all possible truths for P and Q. So I'm not going to go through and explain all of these, but let's do a cross comparison. We see that across the top, we have P, Q, not P, and not P or Q. We have truth, truth, false, truth. And then the second row, truth, false, false, false. And then false, truth, truth, truth. And finally, you see it is accurate with false, false, truth, truth. Great. So that's pretty impressive. Test number 1. Let's go to test number 2. Simply feeding in the exact question, so to speak, or the logic at the top. Let's see what our answers are. A quick comparison. You'll see that we have truth, 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 false, truth. And line number 2 is accurate as well. And line number 3, false, truth, false, 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 all the way down to false, 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 truth, truth. So I'm going to just let you visually compare. You're going to find out that as we go with sort of escalating levels of complexity, you'll see that it maintains its accuracy. So let's go all the way to the next table where we see we have the same 4 lines with the same logical question, and we're getting the correct answer. Now we're going to move on to test number 4, P and Q, or P or Q, and we see we get the same 4 rows with the correct answer. And it continues. We go halfway through with a P and Q and implies R, and it has the correct number of rows, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and it all starts with the truth all the way across the top, and we've got false all the way across the bottom, except for truth. You'll notice that these are in fact correct as well. Let's move to number 6. This one's pretty significant. You see that we've got various different columns across the top. First, we've got PQR, and then not Q, and then we've got P or not Q, and then not R, and then we've got the kind of complicated one that runs off the side here, which is not or, not Q implies not R. And guess what? Same level of rows, we get the same answers. So we're getting validation here. This is not the web browsing version, and certainly there could be a little bit of memorization in here, but these are straight up logic truth table tests, and we're seeing that we are getting some real indication that there is high level Boolean logic built into GPT. And I'll give you these last 3 pretty visual. You can freeze these or grab screen caps, do whatever you want. Love to hear your thoughts in the comments on any of these. Moving on to the last 2, you see that we're getting a lot more sophisticated, and it's showing its work in each case. And now we're getting the truth tables, and I've gone through and vetted these. And in fact, yes, we are getting our correct answers. So let's look at the last 2. If we look at the truth table for all possible truths for the value of P and the corresponding truth value for the entire expression, here is the truth table. This one is a little bit different, as you can see here. So we've got just the logic across the top. So not P, false, truth. And then it's interesting because it actually expands beyond the negation truth table answer that we see here. Let's see what its logic is. It says that these are both logical operators that negate the truth value and the operand that is directly follows it. And we see that the expression is essentially saying not P or not P, which is always equivalent to not P. So why do we get this extra 2 columns over here? Not necessarily saying that this is inaccurate because it does contain the correct answer here, but it might give us a little bit more clarity than even our negation truth table gave us. Let's try one last one, a conjunction truth table. So in this case, you see that we've got P and Q, and the logical operators you see there true if both operands are true. So if both P and Q are true, then that's true. So the truth table that we get back, again, 3 column. This is really the most complex of the ones that we've done. So we see truth, truth, false, false along the side under P. Then we see truth, false, truth false under Q. And then finally, we really get our answer to this truth table, which is truth false, false, false. We see that that one was accurate. So the idea behind all of this is that if you can have arbitrary depth nested collections of ands and ors and nots, you could resolve what they mean. That's the kind of thing that lets you go beyond the pure templates and natural language output of what everyone's calling generative AI into something which is more logic-based and arbitrarily deep computation-based. And that really is where reasoning comes from. And that is where I think if you want to skate to where the puck is going with language models, you can focus on its ability to reason and allow for deep computation against your data sets. Thanks again for watching the 10 tests of Code Interpreter with the truth tables 10 tests. Thanks again. We'll see you in the next video.